Hi, our next lesson is 6.4, using trig to find sides. So the objective is, how do we use trig ratios in order to solve for missing side of a triangle? So you've already learned about the three ratios, sine, cosine, and tangent, and how to find the ratios if they ask you for tang, sine, cosine, stuff like that. And of course, you also learned about SOHCAHTOA. Now you're going to go a step further, and then they're going to give you a missing side, and then you have to use what they give you in order to find that missing side. Okay, so to elaborate more, it's ask you, what are we given? We're given one angle other than a 90 degree and then one side. So that means you're going to have the two angles that are in that triangle, the 90 degree and what they gave you, and then a side, whether it's the bottom of the triangle or the opposite of that angle. What are we looking for? We're looking for that missing side. And the strategy is to set up a proportion and to solve for the variable. So if this sounds confusing, we're going to do examples based on that. So for the first example, they gave us a right triangle. We know it's a right triangle because of the 90 degree marker. And they gave us a side, the bottom part 32, and then the angle 28 degrees. We have to find x, the height of that triangle. Some of you might try to use a squared plus b squared equals c squared, but in order to do that, we need to have two sides. In this situation, we just have one side, and we're looking for another. So the first thing you would do is label the sides. You know the three sides, which is the hypotenuse, the adjacent, and the opposite. So in order to figure out which is which, first thing we know that what's opposite of the 90 degree marker is the hypotenuse. And now we're going to base it off the angle, which one's going to be the opposite, which one's going to be the adjacent. So whatever line, whatever side is closest to that angle is going to be adjacent. And then what's opposite on the other side is going to be opposite. So once you have that label, now based on the information that's given and what you have to find, will determine whether you use SO, CA, or TOA. So since we don't have the hypotenuse, but we have the adjacent with the 32, and the opposite is what we're looking for, it's an O and an A, we're going to be using TOA. So I'm going to highlight that, so that way we know that we're using TOA. All right, now we're going to set up the proportion. So TOA, tangent, it'll be tangent whatever angle, it's tangent 28, over opposite over adjacent, which will be x over 32, as you see there. So now we're going to cross multiply. We can cross multiply, get x equals tangent 28 degrees times 32. But now we got to go a step further. We have to find the tangent of 28 degrees. So this is where you use a calculator. You press tangent and then put the number 28, and then you should get your value of 0.5317. There might be a longer number after the decimal, but we'll just stick with 4 digits after the decimal. We'll multiply those two, and then we get 17.0144 and whatever number. But since they ask us to round to the nearest tenth, then it will be 10, x equals 17.0. And that is our answer. Okay, so let's try another example. Again, they ask us for the missing side. What is that missing side? And then round our answer to the nearest tenth. Okay, so we have a right triangle. They have 64 degrees up here, 15 on the side, the length, the height. And this side has x. This is what we're going to look for. First thing to do, we have to label which one's the adjacent, opposite, and hypotenuse. We know this 90 degree, opposite that, the side opposite is going to be the hypotenuse. Now, most of you are used to seeing the angle at the bottom, so you might switch things around, so be careful. Whatever side is next to the angle will be adjacent. And then whatever side is on the other side of the angle is the opposite. So most of you might switch this up and put adjacent at the bottom, opposite on the side, because your mind is used to seeing the angle at the bottom of a triangle, and then the top usually is left empty. Don't get fooled by that. However you're going to label the side, that is determined by where the placement of the angle is. All right. So now we'll look at what information we have. We have this side, 15, which is adjacent, and what we're looking for is a hypotenuse. So, okay, we need something that has an A and an H. Ka. So I'm going to highlight that one. So we know we're using cosine, and then the ratio for cosine. So we're going to set it up, and it's cosine 64 degrees equal 15 over x, adjacent over hypotenuse. All right, so now we cross multiply, and then we're going to find what is the cosine of 64 degrees, which is 0.4384. There's other numbers behind it, but just stick with 4 numbers after the digit. Divide in both sides to find x, and then we get x equals 34.215, whatever number, but since we're rounding it to the nearest tenth, it's going to be x equals 34.2. And there we go. We found the hypotenuse. All right, so again, your labeling of the sides is determined based on where the angle is placed. Whatever side is next to that angle is adjacent. What's on the other side of that angle, that side that's on the other side, is opposite. And of course, hypotenuse is always opposite the 90-degree marker. All right, so now we're going to apply this, what we learned, using word problems. So it says Diego used a theodolite to map a region of a land for his class in geomorphology. Geomorphology. That sounds so hard to say. But to determine the elevation of vertical rock formation, he measured the distance from the base of the formation to its position and the angle between the ground and the line of sight to the top of the formation. The distance was 43 meters and the angle was 36 degrees. What is the height of formation to the nearest meter? All right, so they already gave us a diagram. In this situation, if there was no diagram, you would need to sketch something. I know most of you are used to, with visualization that helps you to understand the problem, sketch something. For those who don't need to sketch, then and able to solve, that's fine. But usually with geometry, you need to sketch something. So we have our triangle. They told us that we're looking for the height. They gave us the angle, degree, which is 36, and then the bottom part is 43 meters. That's the distance. So again, first thing, we're going to label the sides. We already know what's opposite of the 90-degree marker is going to be the hypotenuse. This angle, 36, what's near it? 43. So that means near, next to, is adjacent. And on the other side of 36, that side is opposite 36. All right, so now we look at the information they gave us and what we need to look for. We need to look for the height. The height is going to be the opposite side. And they already gave us the adjacent. So it's going to be OA. Which one are we going to use? We're going to use the tangent ratio. So it's going to be TOA. So now we set up the ratio. We got tangent 36 degrees equals x opposite over 43. We cross multiply. We find the value for tangent 36 degrees, which is 0.7265, times it by 43. We get x equals 31.23. And since they want us to round it to the nearest meter, it's going to be 31 meters. And that is the height of the formation. So again, you're using the ratios, either SOHCAHTOA, TOA, set up the proportions, solve for the side, the missing side, and then get our answer. Right. So think that was the last of it. Yep. So again, just as a recap, when it comes to using the trig ratios to find whatever missing piece, what is given is an angle other than the 90-degree and a side. What we're looking for is a missing side. And in order to find that missing side, we set up a proportion using the ratio to solve for the variable. And that's using trig to find missing sides. Right, so if you have any questions, you can always email me. I can provide you more examples for you to understand. And yeah, so this concludes our lesson. It was a short one, but again, if you need help, ask. Okay. Have a good day.